Hey, so how'd you spend your weekend? Was it making a construction paper diagram that explains how the sun moves through the sky? Because that's what I did. And your first question is, okay, you're an adult man. Why did you spend your entire weekend working on a grade 6 science fair project? Well, the answer is that like how the sun moves through the sky is actually pretty important to us humans, like both historically and now. Like it's how we originally figured out a system to tell time, and it's why we have seasons and all the rest. But it's also kind of complicated. Like I have trouble wrapping my head around it because all the individual parts make total sense, but there's a lot of angles and it's all in 3D, so I get a little messed up. And since I don't really understand how something works until I feel like I can explain it to somebody else, I built this to explain. So why is the sun in different positions in the sky depending on where you are and what time it is? We're going to find out. And to be perfectly clear, the sun does not move. It only appears to move through the sky because of the way that the Earth moves. So everything we're going to talk about today totally has to do with the way that the Earth is moving or where you are on the Earth. And one of the most obvious things that affects where we see the sun is what time of day it is.
So as you know, the Earth is a sphere. So if you look at it from the top down, it's going to look like a circle like this. And the Earth spins around its poles, the North Pole and the South Pole. We can pretend like there's a rod that goes right through the Earth and it spins around that axis like this. Okay, but because only one side of that sphere of the Earth can face the sun at any one time, that means that half of the planet is always going to be in shadow. It's going to be dark. That's what we call night. And it's going to be lit up on the other side. So depending on where you are on the planet, right? You can sit here, you can pretend that you are this little red dot, and as the Earth spins around like this, you go from daylight into nighttime. You see the sun over here, or it would be setting in the west. You then go through the shadow like that, and you pop out on the other side. You're now going to see the sun in the east, so sun rising. And then you're going to continue on until the sun reaches its highest point in the day, which we call noon. And if you are further north, closer to the pole, you still travel in this circle here. It's just a smaller circle, but you still go from day to night, through the night, sunrise, and reaching noon. So you travel on a smaller circle, which we would call our line of latitude, but you're still spinning around the same as you would on the outer line here, which is what we call the equator.
But the path that sun takes through the sky, that highest point that it reaches, will not be the same for everybody. It is going to depend on how far north or how far south you are from that equator. It depends on your position on Earth.
So from here on, we're just going to be talking about noon, where we're closest to the sun like this. So everyone will be along this edge here, facing the sun. And an important thing to realize about the sun is it's so far away and the Earth is so small by comparison that all of the sunbeams coming in are completely parallel to each other. And where we see these sunbeams coming in is where you're going to see the sun in the sky. So if you are standing on the equator right here and you look straight up with this arrow, you will see that it points directly into that sunbeam right there, which means that if you were to look directly overhead at the equator, you would see the sun above your head. But as we mentioned, that changes as you go further north. So if you go to a higher latitude like this, you can see your straight up is now out this way and the sun is coming in this way. So if you were to look straight up, you would not see the sun. You would have to lower your gaze until it met up with this line here. And in fact, this angle between your straight up and this sunbeam will be the exact same as this angle here, which is your latitude, how many degrees north you are. So just another way you can think of latitude is the difference in your straight up from straight up at the equator. So this angle will be the same because that's a property of parallel lines. When you have parallel lines and one line intersecting both of them, you end up with the same angle. That's just a geometry property. But you could measure it and you'd find the same thing. And of course, like always, the sun is only lighting up half of the Earth like this. But so far, we've been making one really big assumption here, which is that the poles, the north and south poles, are perpendicular to the path that the planet is taking around the sun, perpendicular to the orbit. And that is not what happens at all. The Earth is actually tilted by 23.5 degrees. There's an angle here between where the poles would be if they were perpendicular and where they actually are, and that's 23.5 degrees. And how that affects where we see the sun is you can see that us here at 40 degrees north have moved down like this. The angle of the incoming sun is actually now going to be higher. It's going to be closer to being straight up for us because we've subtracted this angle right here, the tilt of the Earth. So we actually will now see, we take the 23.5 degrees away from that 40, so the sun is only going to be at 16.5 degrees declination, which means that we're actually going to see that at almost 74 degrees above the horizon. Actually a pretty high sun. Another thing you want to notice though is, remember this line of longitude here. That's the path that we sort of travel around as the Earth rotates like this. And you'll notice that more of it is in the sun than is in the shadow or the night, which means that the days are going to be longer when it's tilted like this, and the nights are going to be shorter. It's the exact opposite for the southern hemisphere though. You'll notice that down here, the day is a lot shorter and the night is a lot longer. So in the northern hemisphere, during the summer, we get more sun. That is why it is warmer and hotter in the summer. Another key thing to notice too is that because we've tilted the Earth, there is a spot that is not the equator at which the sun is going to be directly overhead. And this line of latitude is what we call the Tropic of Cancer. You probably remember the Tropic of Cancer is one of the things that you had to learn in elementary school, I'm sure, when you were like learning maps and stuff. But what the Tropic of Cancer actually is it's the furthest point north on the Earth where the sun will be directly overhead on the summer solstice. This right here, by the way, that's the Milky Way galaxy, and definitely not some glue that I accidentally smeared all over this at the last minute. There's one more complication though, and that is that this angle, this 23.5 degree tilt, doesn't change throughout the year. It's always pointed in the same direction. So as the Earth rotates around the sun, orbits around the sun, this is still going to point in the same direction, but we'll end up on the other side of the sun with the sun shining this way. And now you can see that that North Pole is pointed away from the sun, and somebody at 40 degrees latitude is going to be much, much higher up, and the sun rays coming in like this are going to be much, much more shallow. And once again, we only have half the planet illuminated in night. So now you can see that in the northern hemisphere, the days are much shorter. More of the day is spent during the night. And the southern hemisphere has more time spent in the day and less in the night. So this is what we would call the North American winter, because there is less sun heating up the northern hemisphere. We have shorter days. And in the southern hemisphere, they are going to be experiencing summer. They have the longer days and everything like this. You'll also notice that it will be a line at the bottom here where it is going to line up directly to the sun being overhead, and that is what we call the Tropic of Capricorn. So that's what the tropics are. They are the extreme north and the extreme south, where the sun will be directly overhead at least once a year.
So there you have it. That's why the sun is in different positions at different times of day and different times of year, and depending on where you are on the planet. Hopefully you found this informative. Hopefully you know a little bit more about the sun and the path it takes through the sky. And if not, hopefully you just appreciate my construction paper crafting skills. Anyway, I'm really hoping for an A+ from a 6th grade science teacher. So wish me luck. Got any questions? Drop in the comments.